All right, so before I get started, are there any questions from the last week? Because if so, I do want to answer those. And if not, I do want to show just kind of where you can find the notes again for today, as well as the code in case you don't have the code so that you can kind of download it onto your computer. So again, if you have any questions, just ask them in the chat. And if not, I'm just going to quickly show you guys where you can find this stuff. So if we go to Google Classroom here on the actual classroom, I have posted the part 3 notes, and this right here will cover everything that we do for the day today. So you can see kind of what we covered last week, and if you need to download the code again, if for some reason you don't have it, there's a link at the bottom of the page, and it's right here, and you can find it. So day 2 was our last week. And so to download, you would click right here, this green button, and then download zip. Someone asks, do I have to do the beginner work? No, you don't need to. Especially since if you're in this meeting, you kind of should be familiar with the concepts we cover. So those are for the beginners to make sure they kind of understand the material from the beginner lessons. So since you're here, it's totally fine if you don't do it. It's mostly for the beginners to do some kind of, programming to get started. And later here for the advanced, we might do some fun projects. But yeah, as of right now, there's no real like work you need to do yet. Okay. So once you have your code, I'd like you guys to open it up, and I have it open here with my editor. I believe this is the one right here. Yep. So if you remember last week, we created a somewhat playable version of the game, and I'm running it in slow motion so that you guys can see what's going on, where we basically have the player start, then they fall, they collide with this platform, and then they can jump off, they can screen wrap, and collision detection works perfectly. We also resolve the collision by making the player jump. So we kind of have this to the game. And so with this, we could actually create something that now the player could control, and things actually happen in the game. So the goal for today is going to be to let the user control the player, I should say, right? So when we press the arrow keys on our keyboard, we actually want us to be able to control where we put our player. And then also we're going to add a bit of more movement to our game. So we're going to have the platforms kind of go down. And you'll see what I'm talking about at the end. Okay. So Sahil, can you confirm that this is visible here?
Looking at main right now, yeah.
Like as in the text on the presentation, just to
Oh
make sure
yeah, yeah, it looks
it's
good.
big enough. Okay, that's good. Okay, so all right, the first thing we're going to cover. So let's take a look at our document. So this is where you can actually follow us along. So I believe I opened it. Where did I open it? Let's find out. It's right here. So over here, I just want to show this because I do want to make sure that you know this exists. So if I'm ever typing too quickly, you can always look back here. You can also copy from here. So the first thing we're going to do is actually add this user input that I was talking about. So we have the game. Now we want it so that when we press things on the keyboard, things actually happen. So what we're going to do is in jumper update. You can see even Sahil's kind of created a bit of room here. We're basically going to get all of our input. So Sahil, do you want to talk about
Yeah,
this?
yeah. So over here, we're going to be getting basically like a sequence of Boolean values or like a list of Booleans, right? And that's going to represent the state of every key on the keyboard. So if we get a Boolean, right, and it's true, that means that that key is getting pressed down. And if it's false, it means that it's not getting pressed, right? So then we can use that list, which we're storing in the variable pressed, to get the state of a current, like a key using constants, right? So this would be getting whether the right arrow on your keyboard is being pressed down or not,
Yeah.
right? And then using that, we can do different things.
Right. So what pygame.key.get presses again, it just returns like this list of booleans as Sahil mentioned, right? And what we can do is we can index it with one of our keys on the keyboard to find out if it is currently pressed or if it is not pressed, right? Um, and that's really all there is to it. So if you actually see these keys right here, so for example, k_right, uh, they're just all numbers, and when we index them into this kind of list of booleans is what you can think of it as, we can figure out whether or not that key is pressed. And if you actually want to see kind of all of the other keys, what you can do is actually see over here, right? We linked them all. So for in this case, we're going to use k left and k right. And those are the arrow keys on your keyboard. But if you want to do something else, you could find a whole list by clicking this link. So let's do that. So when we press the right key, we're going to want our player to do something. And so what we'll do is we'll actually implement this in our player. And so you might notice this player.moveRight and player.moveLeft, they're currently not methods, right? So they don't actually exist in our player. We haven't implemented them. We'll do that in just a second. So don't worry that they don't actually exist. And if you're getting some kind of error from it, again, don't worry about that. So it's move left, right? I'm going to get rid of this space here. So what this will do is every single frame, we're checking the current state of all the keys, and then we're checking is the right key pressed, is the left key pressed. Should be pretty straightforward. So now let's actually implement this move right and move left. So Sahil, do you want to explain this bit, or should I go over it?
If you could, that'd be great.
Okay, so I guess type it out then. So basically in our player, we're going to have two functions and they're going to be move left and move right. And actually before you go for the acceleration, I want to show what would happen with the velocity, right? So what we want to do is when they press move left, so when they press the left arrow, we want to call move left and we want the player to move left. So one way we could approach this is by setting their velocity, because their velocity kind of defines in what direction they're going to move. So you can just set this to some value like negative 0.5 and positive 0.5. So negative left for negative 0.5 will be that. And what we're going to do is,
Sorry, what value did you say again? Could you
so
just type it for me?
you want to adjust the x velocity, right? So x velocity is referring to our horizontal movement, and when we press the left and right keys, we want our player to move left and right, right? So what we're going to do is we're going to add to our x velocity, well, actually we're going to subtract, right, from our x velocity when we want to go left, right? So that's going to make it go left, and then if we do move right over here, what we'll do is add to the velocity. So pay attention that we're not just adding to the velocity, but we're adding to the x part of the velocity, so the horizontal part of the velocity. And so now what you might realize is, so we're calling move left or move right every frame based on kind of what is being pressed. And if both are being pressed, so move left and move right are being pressed, then both of these get called, and they're getting called every frame. So what's going to happen is we're going to keep subtracting, or we're going to keep adding to our velocity. And what that's going to do is our players are going to speed up really, 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 really fast. Because if you imagine, say my game runs 60 frames within a second, that means after holding the button for a second, my velocity is going to be kind of 30 or negative 30, right? And that's going to mean our players moving really, really, really fast, right? And that's not what we want. We want our player to be moving at the same speed as long as they're pressing the key. So what we're going to do actually is in update over here, what we're going to need to do is reset this x velocity. So what's going to happen is in the update, we're going to tell the player to move left, move right, and that's going to set their x velocity to one of these values. So if they're pressing left, it's going to subtract 0.5, so it's going to become negative 0.5. And if they press right, it's going to add 0.5, so it's going to become positive 0.5, right? And we're going to use this value inside of update over here to adjust the position, right? So you notice we're using this velocity, the change in position, to figure out how the player should move, right? And once we've actually applied this change in position, we're going to reset it to 0 so that then in the next frame, when we call move left and move right again, what will happen is, it'll again become either negative 0.5, it'll become 0, or 0.5, so positive 0.5, right? And this will repeat until the player lets go of the key, in which case, right, move left or move right will stop being called, which means update will just reset to 0, and of course, we don't want our player to be moving left or right when the keys aren't being pressed down, right? So we do want this X velocity to be a reset, right? And lastly, before I forget, if you remember here in init, so in player init, right, we actually set an initial velocity, and we set that to 0.5, and that was just making the player go to the right. However, that was just there for testing purposes. Of course, in our game, we don't want them to initially kind of move, so we're just going to set that to 0. So make sure you change this to 0, and that means that the player's initial x velocity is just going to be 0. They're not going to be move at all, right? And now what we're going to do is we're going to actually run the game just to show what happens. And you're going to notice I can press right, I can press left, and hopefully it looks smooth enough for you guys so that you guys can see what's going on in the meeting. Again, I'm running the game in slow motion so that you guys can see kind of what's going on. On your screens, it should be, a lot more rigid. So Ishan asks, in the PDF, you changed the acceleration instead of velocity. That's a great question, so I'm guessing you're following along with that. We are actually going to use acceleration in just a second. I just wanted to show what would happen if you used velocity instead of acceleration, because so it's pretty clear that if you set the position right, it's going to teleport around, right? Because we don't want our player to just snap around the screen. We want them to move smoothly. So we can try setting the velocity, but what you're going to notice now is that when I press left, they start moving very sharply. On your screen, it's going to be even more apparent, right? And we can actually increase these values just so that it's more clear what's going on here. So I'm going to set it to like 1.5, and it's going to move really fast now, right? And what's going to happen is the second I press my key, the player will start moving at its full speed, and once I let go, it's going to stop right away. And the same thing will happen when we go left, right? So the second I press it, it's going. The second I go, it's stopping. And depending on the game you're making, this might be the result you want, and that's perfectly fine. And I want to show this because maybe that is what you want. But in our game, I'd actually like it for our player to move smoothly. So when we press right, they're going to accelerate up to a certain speed, kind of like how a car in the world would accelerate. It wouldn't just instantly start going 100 kilometers down the highway. You would press the throttle and it would speed up until it reaches 100 kilometers per hour. The same thing is basically what we're going to do with the player. They're going to accelerate, and that way, it's going to start moving in a smooth kind of manner. So it's not just going to instantly start going, it's going to kind of accelerate to that. And the same thing will happen when we let go. It'll kind of decelerate. So it'll move just a little bit more before coming to a rest, or coming to a stop. Sorry. So
Oh,
let's change that. Yep.
apologize. Can you show jumper for a moment?
Yep. So over here in update, all we do is this. So everything else is the same as previous week. We basically get the pressed keys, and then we check if the right or left is pressed. And this is also available in the PDF. So yeah, if you ever want to look back.
Okay, that's what I needed. Okay, thank you very much.
Okay, awesome. Alrighty. So let's go back here. So we did the velocity here, and this is kind of what your guys' version should look like as of right now. But we're going to want to do smooth motion. So instead, what we're going to do is we're going to use acceleration. And so as you see, Sahil just replaced velocity with acceleration. And then over here in update, we're also going to have to reset the acceleration to 0. So right over here, we're going to do acceleration.x equals 0. So let's see what happens now that we're using acceleration. Ideally, our players should kind of start moving in a smooth fashion. So let's run the game and see what happens, right? So right away you notice, wow, my player is going really fast, but you can notice that the movement is pretty smooth. And so what's actually happening is the acceleration is affecting the velocity, right? But there's nothing kind of slowing down that velocity. So once we press right on our keyboard, right? What happens is we add a bunch to our velocity, but then once we stop accelerating, nothing changes basically. And so what we need to do is we need to kind of resist this motion in some way because I accelerate the player left, right? And then I let go, and there's nothing decelerating the player in the other direction. You can see they're kind of just moving across the screen. And then I have to slow them down by accelerating them in the opposite direction. So we're accelerating the player essentially, but then we're never decelerating them back. Does that make any sense to you guys? So I think I explained this also in the PDF. So if we just take a look here, essentially, right? Once we hold the arrow key, our player accelerates to a really high speed, but they're able to just accelerate endlessly, and that's not what we want to have happen, right? And once we let go, we also want the player to kind of decelerate. So let's implement that, right? So what we're going to do is we basically need to somehow resist this motion. And a really easy way to do this, I'm going to go back to player here, sorry. So in player.update, a really easy way to do that is actually to just constantly multiply the velocity by some value. So let's try 0.95, right? Just to see what happens. So self.velocity.x times equals 0.95. And so what's going to happen here, right, is basically every single frame, right? Remember that update is called every single frame. We're going to multiply our x velocity by 0.95, which is going to decrease it just by a little bit, right? It's basically going to take 95% of the previous velocity, right? And so you can imagine how proportionally, right, when you have a really big velocity, well, now our velocity is going to decrease by a big amount, right? And when it's a tiny velocity, well, then it's going to decrease it by a tiny amount. And this just ends up being a really, really good way of simulating resistance, right? So in real life, right, you can imagine, right, when you're driving down the highway, right? I don't know if you all can drive, but when your parents are driving down the highway, they can't just infinitely accelerate down the highway. At a certain point, their car is going to stop accelerating. Or I think a better way to think about it is maybe a race. Maybe they shouldn't be going the fastest their car can go on a highway, but imagine race car drivers, right? At a certain point, their cars stop accelerating. And the reason is because there's a lot resisting that motion, right? So you have things like air resistance. So you're pushing against all that air, right? Or you have things like friction, right? So in real life, there's a lot that resists you from just infinitely accelerating and going at really ridiculous speeds, right? And in our game, there's nothing like that actually being simulated. So a really easy way to do that is just by multiplying our x velocity, right?
Yeah.
And so
Sorry, I just want to say, in life, these forces multiply exponentially, which is why at a certain point it becomes like unreasonable.
exactly. So the same is basically going to happen with our velocity. It's going to scale with how big it is, right? So when the velocity is really big, it's going to resist a lot more. And what will actually happen as well is this acceleration, right? It never changes, right? But the amount of resistance is going to increase the faster it's going, right? So at a certain point, what's going to happen is the resistance is going to resist equally as much as the acceleration is trying to, you know, push forward. And so the two will cancel out, and so the player will reach kind of a top speed, and they're not going to accelerate any faster, and they're not going to start decelerating either. So they're going to kind of reach this equilibrium point, I guess, if that's what you want to call it. All right. So let's actually see this in action. I know I've been talking a lot about this, but I just kind of want to explain why we're multiplying by 0.95, because otherwise it's not really obvious what's going on here. And this same explanation is kind of available in the PDF. So what happens is, okay, this isn't a really good example because I think we're just reaching the top speed way too quickly, right? So let's try bumping up our resistance value here. So let's make it like 0.99. So hopefully our player will resist our motion a bit less. And it really is difficult to show right now. And there's one good reason why this is happening, right? So in our actual game, we tweaked these values a bunch to get a result that really showed this acceleration effect. But basically what we're going to have to do is we're going to have to increase this value a bunch, right? And then increase how much we're accelerating by, right? So instead of doing that, we're going to do 1, and hopefully it'll be more visible, right? So it really comes down to, so now it's going really fast, right? So we need even more resistance. So actually we're going to have to decrease the value, right? And that's kind of the process we went through. So something I do want to point out is, like, so far it probably appears as though when we've made this game, right, as you guys are following along, we've made every single perfect decision. We haven't really made major errors in the design of our game, right? But in reality, we kind of prepared this game in advance. When I created the game for you guys to teach it, this was like a complete mess, really. And I experimented with tons of features, right? Till I got what I wanted. And so when you're making your own game, I don't want you guys to feel that, oh no, I'm not making these decisions. Oh no, I'm running into all these issues. Because that's honestly a natural part of this game development process, right? So don't be afraid. So I don't know if it still shows. I'm imagining that because of the stream lag, it's really hard to see. So maybe I need to resist it even more, like 0.9, and then increase the velocity, the acceleration, sorry. Just so you guys can, yeah. It is really not showing.
That shows it pretty well, actually. You can see it like speeding up and then getting like a max speed.
Maybe. Here, let me try even higher acceleration. So I don't know how well that's showing. But hopefully on your own screens, you will actually notice that we're adding a bit of acceleration. So let's revert all these values, right? And let's talk about a problem with what we've actually implemented, right? So you might think that we've implemented this, and sorry, I need to go back here. So let's do 0.5 again like we were doing before, right? So this is what we had before. And on your guys' screens, this might work perfectly fine, but actually, I mean, I could ask you guys, but I'm thinking chances are you've probably read ahead in the PDF, right? Basically, what's happening is, for us, it might appear this is working great, but maybe on another computer it won't appear great. And the hint here is delta time, really, right? So the problem is we're doing this, but we're not scaling it by the amount of time that's passed. We're scaling it by the amount of frames that have passed. So if a computer runs more frames in a second, right, then this line will get called more often, which means that they will experience more resistance. And then maybe a computer running fewer frames in a second is going to experience less, because this line right here, which is supposed to be called every single frame, is going to get called less frequently, right? So while position and velocity are being scaled by the time, right? Or should I say velocity and acceleration, right? This line over here is not being scaled by delta time. So we actually need to fix this, right? So let's think about how we could fix it, right? Maybe you're looking at the lines above and you're thinking, okay, well, let's multiply it by delta time, right? But let's actually think about what kind of effect this will have, right? If we multiply this value by delta time, right? Let's think about what delta time really is, right? When the amount of time between frames is higher, then delta time is higher, right? Because more time has passed in between those two frames. That should make sense. And when there's more time between those frames, that means that less frames fit within a second, which means the computer's running fewer frames, right? So what's going to happen is this value is going to get kind of larger when the delta more time has passed, and smaller when less time has passed. And when this value is smaller, remember that we're multiplying our velocity by this, right? So the smaller the value is, the more sharply it's going to decrease, which means basically, right, on a computer running more frames, right, it's going to already be calling this more frequently, but now because it's calling it more frequently and also multiplying by a smaller value, they're going to decelerate extremely quickly, right? They're going to have a ton of resistance applied to their motion. Whereas on a computer with fewer frames, well, now this value is going to be really large, right? It might even exceed 1, in which case it's going to start increasing in speed, right? And it's going to have less resistance applied. So basically, you're going to get an even worse effect if you just multiply by delta time, right? So what we actually want, right, is so that we apply more resistance on slower computers and less resistance on faster computers, right? And that will kind of negate the fact that we're calling it more frequently, right? So let's think about how we could do this. Well, what we could do is rearrange this 0.99, which we had before, into 1 minus 0.01. So instead of 0.99, we have 1 minus 0.01, right? And if we now take this value over here, 0.01, right? If we multiplied by delta time, right? Then when delta time is greater, when we're running at slower frames, this value will get larger, which means this whole value, because we're subtracting this from 1, will get smaller, right? Because it gets smaller, more resistance will be applied. So on greater delta times, more resistance will be applied. And then when this value is smaller, well, then this value is going to be smaller, which means this value is going to be much more closer to 1, which means less resistance is applied. If we multiply by 1, you can imagine nothing happens to the value, no resistance is applied. If we multiply by 0, right, that means we completely zero out the velocity, the player stops moving. So it's kind of this value that scales from 1 to 0, which determines how much we kind of fight against the velocity by, right? The one last thing to consider is, in this case, we're multiplying 0.01, so if delta time happened to be, for some reason, and this really shouldn't happen in your game, but if it were for some reason to be greater than 100, then this value is going to go negative, because this is going to be, like, for example, 200, right? Because, 200 times 0.01 is going to be 2, and then you're going to get negative 1, and that's going to result in the player, going in the opposite direction, because what's going to happen is so much time has passed that the resistance has pushed in the complete opposite direction, because that's just kind of what we've written here, and we don't want that to happen. So what we're going to do is, if this value happens to be smaller than 0, then we're just going to set it to 0. And the easiest way to do that is to do max. Max, yeah. And so if this value is smaller than 0, right, then we'll pick 0 instead. And that'll solve that problem. And the last thing we should do here is, so we kind of have this magic number over here, 0.01. We don't really know what it's doing. So let's make that a variable, and we're going to call it horizontal resistance. So that's how much we're going to fight back against any horizontal movement. As well, we're going to change this 0.5 magic number into a variable, into kind of how much we accelerate the player. So we're going to have movement acceleration, and I don't remember if we call movement resistance or horizontal resistance, but basically we're going to have another value. So you're going to notice we're actually going to use a very small value for the acceleration, and as well for the horizontal resistance. And these values were just the ones we picked because once we had all this delta time implemented, we really tweaked these values. So obviously we're not coming up with these numbers on the spot. We've kind of come up with them in advance because we've tested the game. But in your games, when you're making them, you're going to have to actually, test your game and come up with these values, right? You can sometimes guess what a good value would be, but it always comes down to testing. Awesome. So now let's see this kind of acceleration-based movement in action. So when we press right, and oh no, what is going on? I think we didn't, oh no, we did. Okay. Did we do something wrong? Let's see here. If I run this at normal speed, does this run correctly? No. Clearly our value is way too high somewhere. I'm not too sure where. I think one of these two might be incorrect. So that's what I mean. It comes down to testing. I think we might have not enough
Oh, yeah, I think I'm
resistance
using the
plug.
old value. I don't have the new value with me, so.
Okay, I'll have to take a look here on the PDF then. Okay, so do 0.05 and 0.025. So where do we go wrong here? This is weird. I don't know how we've run into this. Let's take a look here. So I'm gonna actually open up what the final result should be. So I'm gonna do that in just a second here. So if I actually run the other version, like this is moving a lot more like what it should be. So if we look in player over here, this was our final version. Let's see what we did here. So are these values correct? I'm not too sure. If we paste this in here, let's see here. Did we make an error somewhere? And this cannot take X and Y. This is, sorry. Sorry guys, I'm not too sure what happened here. I don't know why our code is running differently. And we don't take in this quite yet. Alright, well, now it's working. So, I don't know if anyone's been following along here, but is anyone else experiencing the same thing where it's like going really fast? Because I'm not sure if we made a mistake somewhere or what exactly is going on here. Okay. Well, that's good. I'm gonna have to look back at this and see exactly where we went wrong. But basically, this should be the same as what we had before, right? So we have our movement acceleration, we have our horizontal resistance, we have our move left, our move right, and then in here we are multiplying the x velocity by this value, and then setting acceleration to 0. Okay. Not too sure where we went wrong, so yeah, we'll have to take a look later. Anyways, let's move on. So I think now when I run this, what we can see is the player smoothly accelerates to their top speed, right? And I'm running this in slow motion so that you guys can see, but if I was to actually increase the speed of the game back to normal speed, this would kind of feel like what we actually want it to feel like. So, and I'm missing the platform right now, but that's just how it is. We'll have to fix that in a second. And in fact, you know what? Let's fix it just so that we can test this out right now, right? What we're going to do is in the player init, instead of setting the position to 0, 0, we're going to set it to a position we pass in, and this way our jumper class can figure out where the player should start, right? Because later in the game, we're actually going to want to make that change. And in the document, I believe we made this change a lot earlier and I completely forgot to implement it. So let's do that here. And instead of spawning in the platform at, not the platform, my bad, the player at 0, 0, let's center it on the screen. So Sahil, do you want to just type that out real quick? So it's going to look a lot like what we did with platforms, where we get the center screen and then we also subtract half of the width, right? And then for the height, we can just spawn it at the top of the screen. That's perfectly fine. So we can set that to 0. And this way we can much more easily test our game, right? So we save that and we run main. And there we go. So you can see our player kind of accelerates when you run it to the left and to the right. And so instead of sharply moving left or right, what's happening is it's kind of accelerating to the left and to the right. I'm afraid through the meat, it's just not possible to show this well, unless I slow it down again. So let's do that. So all I'm doing here is just I'm telling the game that time is actually running a lot slower than it truly is. And that's giving the illusion of slow motion. So if you see again, my player is kind of accelerating until it increases in speed. So it's a very slow increase in speed, but instead of suddenly changing directions, it's now smoothly changing directions. And that's all there is to this acceleration-based movement. So it's pretty simple, but yeah. It seemed okay to me, but I didn't change any values when you're showing the velocity versus acceleration thing, so maybe something got changed. Yeah, maybe. I don't know. But I'm hoping that you guys aren't experiencing the same issue. And if you guys are, then stick around in the end. I'll help you out with sorting that out. Okay. So the next feature in our game here is going to be the camera. And so what is this camera? Let's figure this out. So in our game, we want our player to move up through the world, right? We want it so that when they jump up the platforms, right, the camera moves up with the player. And as well, we just want the player to move up so that there's a bit of challenge to our game, right? We want the platforms to kind of go down, and then once they go off the bottom of the screen, and then we want them to kind of disappear, and so that the player kind of dies, right? That's kind of the challenge of the game is, can you outrun the camera? I know that sounds very silly, but basically, in our game, right, rather than having falling platforms, what we actually have is a camera that's going up with the player, right? And it's giving us the illusion that everything's falling down, right? Or, in other words, it's making it look like we're going up through the level, right? So, to simulate this, we're going to need to actually know where our camera is positioned, right? So let's figure that out, right? So what we're going to do is we're going to call this just camera Y, and I don't know if Sahil, you want to implement this actually. And basically we're going to start 0, right? We want the beginning to have a height of 0, right? And then as time progresses, we kind of want to move the camera. And in our game, right, we only move vertically. So we only actually need one value to describe this. So that's why I've just called it camera Y, right? And what we're going to do is, as time progresses in the game, we're going to move that camera up. And remember that in our world here, in our game, the negative direction is up, right? So negative Y is going to be up, positive Y is going to be down. So we're going to subtract from our camera's position, and we're going to, just use a value that's small, and we're also going to multiply by delta time. So this is very similar to how we do our position updating in player, right? We're just going to get kind of a speed, so that's going to be 0.1, and multiply it by delta time, right? And so what we're going to have now is Sahil defined this function called update camera position, just to kind of separate this update camera position logic with the rest of it, right? But basically, when we call this every frame, this camera Y is going to decrease, and that way we're going to know, okay, let's position everything kind of higher up, right? And so we'll cover actually in just a second how we're going to do that. But real quick, let's call update camera position in update, right? So all this value is going to do is basically describe the height of our camera. Awesome. Okay, so now let's actually think a bit more about how this camera is going to work, right? So now we have a value that describes where it should actually be positioned, right? But something I have to mention before we actually think about this is that in every video game, and I'm being dead serious now, in every single video game out there, um, or 3D animation software or anything, anytime you kind of have computer rendering, right? The camera is actually always fixed to the center of the world. So the camera never truly moves around. What actually happens in video games or in 3D rendering or anything kind of related to that is the world moves around the camera. So when you move forward, right, or up or whatever direction, what's actually happening is everything in the world is moving in the opposite direction at the same speed, right? So when I move forward, everything in the world moves backwards, and that gives us the illusion that we're moving forward. Now, that being said, this logic doesn't apply to the entire game, it applies to the rendering of the game, right? So things like collision detection, the player is actually going to be moving across the world, right? And it's going to use its position, right? But when we move the camera, right, what we're going to do is we're going to draw everything shifted in position, right? So we're going to keep everything at the same position. We're going to affect like the vector position. So for example, this position over here, right? Or in platforms, we're not going to affect this position. What we're going to do is when we draw it, so inside of draw, right? What we're going to do is we're actually going to shift the position of it so that it looks as though the camera moved up. So in our game, right, the camera's moving up, right? And that's going to be going in the negative direction. So if we subtract the camera position from the position of where we draw, what's going to happen is that's going to be positive, so it's going to move everything down, right? And that way, it gives us the illusion that the camera is moving up through the world. So hopefully that makes sense. Is there any questions about that, or are we kind of clear with that? So what Sahil's going to do here is he's going to have a camera Y parameter in draw, and then when we get the Y position of this rectangle, we're actually going to move it down. So when the camera Y goes up, so it goes negative, then we add to the position. When the camera Y goes positive, then we're going to subtract, and that's going to be negative then, right? So that's kind of how cameras work in video games. And if we had a camera that moved on the X and the Y, then we just use kind of a vector to represent that, and we'd subtract the X and Y positions. Okay. So we've got that implemented, and then we're going to do the exact same thing in player. So in player draw, we're going to pass in camera Y, and then we're going to subtract camera Y from the Y position. And this is the exact same thing, right? And once we have that in jumper, right, since we're updating this camera Y and we're calling this, all we have to do is we actually have to just pass this camera Y into every time we draw. So when we draw the player, we pass in the camera Y. When we draw the platform, we pass in the camera Y. And so that's going to shift everything kind of relative to the camera. So when we move up, everything's moving down. Hopefully that's been made clear, right? And so when I run it, if it runs, it's being a little slow here. There we go. You're going to notice, and this is again running in slow motion, that everything's kind of moving down slowly, right? You can tell this platform is going to soon be underneath my mouse cursor, right? So everything in our world is going down because what's happening is we're increasing the camera Y position, so we're making it go up, and we're drawing everything lower as time progresses, right? So that's kind of how we implement that vertical kind of motion in our game, right? And so to make this a bit more clear, right, we're going to need to add more platforms to our game, right? So we're updating our camera position, right? Now let's add some platforms so that we can see kind of what's going on in our game, right? So for now, if you remember, we temporarily kind of created this list of platforms, right? But inside of it, we only put one platform in, right? But we created a list so that in the future we could just add multiple platforms and everything would be figured out for us. So that's what we're going to do now. We're going to add multiple platforms to our game. So what I'm going to do is I'm going to real quick just comment this out, right? And we're going to create a new thing. So Sahil, do you want to type that out? We're going to create an empty list, and to it, we're going to add a bunch of platforms. So in the future, we're actually going to handle kind of all this creating, deleting platforms in our game, because after all, the game kind of continues infinitely, and we have limited resources at our hands, right? So we can't just create a million platforms, because that's going to make things like collision detection extremely expensive. So what we're going to do is we're going to give it the illusion that the world continues infinitely, but what's actually going to happen is things are going to spawn and despawn and things like that. So if that doesn't make sense, right? If that doesn't make sense, then don't worry about it. We'll cover that later. But basically, for the time being, we can just spawn in 100 platforms, and that way we have some platforms to jump around on and that we can test our game with. So what Sahil has done here is he's created an empty list. He's looping 100 times, and then each time he loops, he just adds a new platform, and we're positioning that in the center of the screen, but we're also adding to the height, right? So we're subtracting, right? Because that means going up, and we're just doing I times 100. And what that's going to do is it's just going to space out the platforms every kind of 100 pixels. So I'm just going to change the indentation here just so it's a bit more readable. So there we go, right? We have kind of the X position and the Y position. So these two look very similar, but with the Y position is also being displaced by kind of the platform number we have. So that's I, right? So let's see what that does. Now we have, as you can see, we started out with a platform, but then 100 pixels later we created another and then another, right? And you might be noticing actually, my player is kind of going off the screen. So I'm going to bring them back to the screen. And 1 second. Where's our player? Oh, he's kind of to the left, right there. Got moving to the left, and I might actually not make it, in which case that'd be very tragic. All right. The point is basically our player appears, but they are able to kind of outrun the camera, and so they're going off the screen. So if they jump high enough, right, they're going above the screen. So what we actually want to do is to fix this specific problem in our game, right? So this isn't really a problem with our game, but it's just a thing that could make the game more playable. Is what we could do is when the player goes higher than the camera, we could kind of just shift the camera up to make sure that the player's always in screen. And of course, if the player falls down, right, then what we can do is we can despawn the player. Yes, is there a question?
I just joined this call. I haven't really been doing many of the advanced classes, and I probably don't have like any authority to say this, but another possible solution you could do is like you could install like a rubber banding feature where like it speeds up how fast the platform moves down after you pass a certain Y value.
So that's kind of what we're actually going to do in our game. Basically, what's going to happen, right, is once the player goes off the screen, we'll compare its position with how the camera is positioned, and if the player happens to be above the screen, we'll basically just force the screen to move up to the player. So let's actually implement that right now, right? So this is going to be in Jumper, where we update the camera position. We're also going to take into account the player position, right? And something else to think about is this, just like every other position in our game, this camera position is in the top left corner of our screen. Now, left kind of refers to the X, but we don't really have an X. We only have a Y. So basically what this is referring to is the top of the screen. This basically means we can just compare the player's position because that's its top left corner. So we're getting the top side of the player and comparing it with the top of the camera, which is also at the top of the screen. And if the player is higher, then we can just set the camera's Y position to the player's position. And so let's take a look at what effect this has, right? Basically, the game will start, the player will jump up, and then when they hit, you're going to notice the camera starts going faster, right? So that always the player fits on the screen. And you can see it increases in speed when the player jumps. And what it's doing is actually it's matching the speed of the player, right? Because it's always trying to keep the player on the screen. Now, if the player falls, obviously our platforms are going to continue moving because we're adding to the camera position, right? But it's no longer accelerating at that same rate. It's just doing this subtraction that we have in jumper. So it's just subtracting over here, right? But when we reach the top of the screen, we're kind of hitting this if statement over here, right? So hopefully that makes sense, right? And lastly, I don't know if there was, I think there was one more part that we need to cover here, which is, so we've implemented camera, and this was just talking about testing the features. So we've centered the player, we've removed the initial velocity, and we spawn in 100 platforms. And that's it. That's it. So I can actually run this in real time for you guys, just so you can see kind of what the game is looking like now. So obviously you saw in slow motion what's going on in the game, right? But when I run it, you can see our game kind of moves up, and it's probably not clear because now it's running really fast and Google Meet doesn't like to have high frame rates. And the last thing is basically we only are spawning in 100 platforms. So at a certain point in this game, right, you're going to notice just in a bit. So 100 platforms is quite a lot, actually. You're going to realize as you go. But eventually, basically, what's going to happen is it's going to run out of platforms to jump on. And so that kind of ties into what we're going to do next week, right? So next week, we're going to kind of start finishing up the game. So you can see it ran out of platforms, right? Because there was only 100 platforms in the game, right? So what we're going to do is we're going to actually start spawning in platforms randomly. So we're going to randomize their positions. We're going to add kind of a score counter to our game, and also we're going to make it so that the difficulty of the game kind of progresses. So make it a bit more of a challenging game that's fun to play. And once we have that, we're really going to have an almost completed game. After that, it really comes down to finishing touches. We're going to add things like the main menu and the game over screens. We're going to make it so the colors change around to make the game a little more exciting. Things like that, right? So we really are getting closer to a final game product, right? And so this, for example, was kind of a good example of a working product of a game, right? And that's what you always want to achieve with your game, right? Before you even try to make the code good and all that stuff, you want to have a working product. And you only get that through a lot of experimentation. So if you are making your own games out there, I just want to give that advice. You don't have to be perfect out there. It might look as though that is the case because of our lessons, but that is absolutely not the case. And so that kind of wraps up all the stuff for today. Remember, you can find the code. I will post it, the complete version, on the GitHub, and that's linked at the bottom of the document. But also, you can find it on the PDF, right? And if you have any questions, I strongly encourage you to stick around. I'll be answering them very happily. And if not, then I hope you learned something new today, and I hope you guys have an awesome week. And so hopefully I'll see you all next week so that we can kind of cover all this final game related stuff, and then we can kind of move on to all the finishing touches, right? So yeah, I hope you guys enjoyed this, and I'll see you guys next week. Again, if you have questions, stick around, ask them in the chat, or use your mic, however you wish.